Okay, so let's get out our graphing calculators, and then you're going to clear it. So second plus 7, 1, 2, make sure everything's all good. And then you're going to go to mode. And then you see right here, it says radians. We want to keep that. And then we're just going to keep everything the same for now. Okay, we're going to go to y equals. And let's see what 4 sine of x looks like. I want you to imagine it. And if you can't imagine it, I'm slightly, very disappointed. So the graph of a sine function is like a sine wave. It goes through 0, 0, goes up and back down. It goes up 4 and down 4, and then it has a period. What's the period? So right here of 2 pi. So this is 6 point something. All right, so that's what it looks like for us. But then, do you remember when we were doing something with polar points? So let's say you have like the point 2, 2, and this is an xy, and then you graph it, and you're like, oh, that's 1, 2, 1, 2. That's right here, right? How do you do this, or how do you write that as a polar point? Well, you would have to do r comma theta. So r is this length, which we know is 2 root 2. So 2 root 2. And then theta is exactly 45 degrees, so like pi over 4. So we would write it this way, right? So if we're doing an xy, it looks the same as if we're doing r comma theta. Also, do you remember how like r comma theta, like we might have something like, I don't know, let's say they give you an equation, you have like r equals cosine of theta, and then we're like, oh, change that to rectangular form of an equation. You're like, oh, okay, yeah, duh. I'm going to multiply both sides by r, and then this turns into x squared plus y squared, and this turns into, what is that? That's an x, right? R cosine theta is x. I know it's been a long time, but I'm just reminding you that we can change these back and forth. This turns into a circle, which we're going to talk about in a second. So I'm going to go back to here. And this was 4 times the sine of x. And then our graph looks something like this. So now we're going to go to mode. And you're going to go to polar right there. So we were in, we had like an xy function, and now we want to be in polar. Press enter. You're going to go to y equals, and then you're going to see, oh my gosh, look at that. R equals, right? So R equals, let's do 4 and sine of, oh, it's not an x anymore, it's a theta. Okay, well that makes sense because it's like r comma theta. There's no more x's, there's no more y's. We're going to graph this and see what it looks like. I think it looks like a circle. And it is! Okay, so if I make this like nice and evenly pixelated, I'm just going to square it out. So see how that's a circle? So that's what I'm talking about, okay? So this was 4 sine of theta. I want you to guess what happens. Think in your head what happens. If this said negative 4 sine of theta, what would happen to this? And what do you think the 4 represents? I mean, actually think about it. Don't just like wait for the answer. So 4, you can count, oh, that's 4. Positive sign, oh yeah, sign is like y values, right? So a negative sign would be the same circle down here with the diameter of 4. What about negative cosine? Where would negative cosine be as a circle? It would be right here. Negative on the x-axis, which this is not an x-axis because this is a polar axis, okay? But it would be like negative x. This would be positive for cosine. Positive cosine circles go over here. Okay, so like circles are really easy to graph. Okay, we're gonna try right here, instead of theta, let's do like 3 theta. And that should do something. Ah, that's called a rose curve. Okay, so we're gonna learn to graph all of these. But what do you think would happen if instead of a 3, that was a 4? So I just want you to imagine what you think would happen. Just take a guess. And then I'm going to change it to a 4. And then let's see if you're right. I tricked you. Yeah. So it's not 4. It's actually times 2. It's going to be 8 petals on your rose curve, on your flower. But it's technically called a rose curve. Okay. So if you have right here. Where is it? Right there. If you have, for rose curves, n petals if n is odd. So 3 theta gives you 3 petals. But then 2n petals if n is even. So 4 theta gives you 2 times 4, which is 8 petals. So there we go. Okay. What else is super cool to look at? Let's do insert 1 plus. And then I'm going to graph that. Oh, that's weird. I didn't mean to graph that. I'm going to actually take this away because this is what's messing it up. Sorry. This is what we would graph. Let's see what that looks like. Okay, so this is called a Limacon, and it looks like a circle, but it's not exactly a circle. It's like there's an inner loop inside this Limacon. So this one would probably look a little bit different. Yeah, so now you can tell it's definitely not a circle. It's like some other shape, okay? And it still has that teeny tiny inner loop. And then I'm going to change that to a 4. And if I change that to a 4, there's no more inner loop. What's that look like? Well, maybe it would look a little better if we did a minus. Yeah, okay, so now it looks more like an apple or a peach, or sometimes I say something else. But technically, it's supposed to be like heart-shaped, so it's called a cardioid. So, you know, like I'm doing cardio, it's good for your heart. So it's called a cardioid, okay, because that has to do with hearts. And then what else is a little bit weird? So maybe we can change that to a 5. And then we can see, okay, so this one is not a cardioid. This one is a Limacon with a little dimple, okay? And then there's other kinds too, but these are all called Limacons. So anything in this fashion. So this is like a negative here, and then this is a sign. So if it's a negative and then a sign, I want you to look at the graph and think about negative sign values and why it's graphed, like, you know, where it is. So what do you think would happen if this was a positive and a cosine? Where do you think all this stuff, all the major stuff would be happening? A positive cosine would be like right here. So basically it would just be like a rotation, right? So it would be like right here, and then there'd be the little dimple over here, and then it'd go out this way. So you can kind of see where things are gonna lie on your graph, things like that. Okay, so we're gonna start graphing them because you do not get to use a graphing calculator on your quiz and on your test. It seems like a lot, but I swear, actually, it's pretty easy to remember, all right? I swear, it really is. So you're going to highlight for real. So you're going to highlight lines and circles and lemniscate. I feel like I'm saying that wrong, but that's okay. Lemniscate, rose curves, and Limacons. So Limacon is spelled with a C, and it has that little, like, thing underneath. It has, like, a little tick mark underneath it. I don't know what it's called. It's not English, okay? So you're going to highlight those, and then you're going to underline highlight. So, like, a line starts out like this. So what's it gonna have? What it's gonna have is like r equals, and then it would be like a secant theta, right? And then r equals something times cosecant theta. So that's lines. A circle is what we just did, like the first thing. So it's r equals some number times cosine of theta. So there's no number in front of the theta, okay? A lemniscate, which is like an awful flower. So it's a flower that's been wrecked. It only has 2 petals. It's either going to look like this or it's going to look like this. Those are the only 2 options, okay? The number in front is going to tell you how long your petal is. So r squared equals a squared. So you're going to highlight these. It's going to look something like that. It's either going to be 0 degrees to start with or 45 degrees to start with. So sine versus cosine. And then rose curves, again, odd, same number of petals, odd n. Even n, it's going to have double the amount of petals. Okay, if n equals 2, 4 petals. If n equals 4, 8 petals. Okay, Limacons are going to have this some number plus or minus some other number. A and B are actually both positive. What the plus and minus tell you is if you're on the right side or the left side, or if you're above or below, if it's like a sine graph, right? So A and B are both positive. So one more thing you have to remember is if A over B is less than 1, then you're going to have this limacon with an inner loop. And then for A over B is equal to 1, you're going to have this, we call it heart-shaped and a cardioid, but I feel like that looks like something else to me. This one, if A over B is between 1 and 2, then it's dimpled, so it doesn't go all the way to the pole, right? That's not called an origin anymore, it's called the pole. And then if A over B is bigger than 2, then it's called a convex limacon. Like these two, I wouldn't say that you have to like memorize these, because when we graph it, you'll kind of see it. But I am going to tell you a little shortcut so then you can memorize them. You definitely want to know this one, otherwise you'll get a little confused, okay? And then a little bit more, and then we'll start graphing. So to graph a rose curve, we have to know how many petals, and then the first petal is important. So the first petal is going to be, if it's a sine graph, then your first petal is going to be 90 degrees over n. So I'll show you what I mean later. And then if it's cosine, you start on the pole, on the like positive x-axis that we think of, okay? And then all the petals are going to be, you can see in the picture, it's always like, if it's 3, it's 360 divided by 3 for each, like, oh, from here to here, that's the degrees, and then that's the degrees, right? So if there's 8 petals, 360 divided by 8, it tells you, like, where to go next. But it's always going to be symmetrical all the way around. So symmetrical around the pole, symmetrical around the origin that we usually think of. Okay, and then blah, blah, blah. And then to graph limacons. So limacons are like this, right? To graph them, really what we really need are these, like, what we think of as x and y intercepts. So x and y intercepts, usually we just plug in 0 and then see what happens, blah, blah, blah. But these are not x and y anymore. This is theta equals 0 degrees, 90 degrees, 180 degrees, and whatever this is, 270 degrees. So really this is a 0, pi over 2, pi, and 3 pi over 2. That's why we're using this. It's always going to be these 4, okay? Okay, let's try some. So you're going to pause, and you're going to look at these, and I'm going to ask you not to cheat, even though I can't see you over the internet. So don't cheat. You're going to turn around your paper. You're going to turn it to the back, and then you're not going to turn it back around and be a cheater, okay? So take a look at it. Just kind of recognize, oh, what does this look like? What does limacon look like? What does the lemniscate look like? And then you're going to turn around. And then, here you go. So go ahead and jot down. Example 1, r equals -4 cosine theta. Example 2, r squared equals 4 sine theta. I know I'm talking faster. Example 3, r equals 3 minus 3 cosine theta. Example 4, r equals 2 sine of 3 theta. Example 5, r equals 5 secant of theta. And then example 6, r equals 5 minus sine of theta. Okay, so you're going to pause the video, do it. And then you're going to label each kind. So what is it? Is it a circle? Is it a lemniscate? Is it a line? Is it a, I don't know, a rose curve? Okay, so go ahead and pause and write it down, and don't be a cheater. Don't turn your paper around. Don't put it into a calculator. Just do it. 3, 2, 1. Okay, we're going to check our answers. So this is a circle. There's no number in front of here. We graphed something that was really similar. This is a circle basically on the left side of the pole, okay? This r squared is a lemniscate. This is going to be a 2-petal kind of thing and go diagonally this way. This one is a limacon. 3 minus 3, yeah, that's always going to be a limacon. A plus or a minus is going to be a limacon. This one specifically is a cardioid. So this is going to have like that perfect little, or that cute little, I'll say, like little heart-shaped, okay? And then it's going to have a point literally in the middle on the pole. This one is a rose. It's almost a circle, but it's not because there's that 3 inside. So this is going to be a rose. It has 3 petals specifically. This one is a line, because really on the other side, this would be our cosine, and that's what a line is, right? So like our cosine right there. Okay. And then this is another limacon. So a limacon, this is a convex limacon because A over B is 5, and 5 is way bigger than 2. Okay, it's going to look like a circle, but it's not a circle. Okay, so here's what you're going to do. So example 1, you're going to take a look at it, and then what is this? Think it to yourself if you're not saying it. And then you're going to write it down, and yes, that is a limacon, okay? With an inner loop, because 1 over 3 is less than 1. So we want to know it has an inner loop. And then it's symmetric to the polar axis, so it's going to be symmetric to what we think of as the x-axis. And then you're going to do your, this isn't an XY chart because we don't have X's and Y's. This is a beta R chart, right? So whatever theta is, you plug in. So I'll do the first 2. So cosine of 0, think about your unit circle. Cosine of 0 is 1. 3 times 1 is 3. 1 minus 3 is negative 2. And then you plug in pi over 2. So cosine of pi over 2 is 0 times 3 is 0. 1 minus 0 is 1. Okay, you do the other 2. Don't just copy me. And hopefully you get these. All right. So then you're going to graph. So what I mean by graph is 0 should go on the, so if this is what we think of as the origin, 0 should go to the right, and then it should be 2 to the right. But then if it says negative 2, you're going to go 2 to the left. And then pi over 2 is up here. So it goes 1 up. So you put a point. And then pi is over here. So 4 to the left. And then 3 pi over 4 is down here. So 1 down. And then you do those 4 points. And then you're going to connect an inner circle. Hopefully you see it. And then you're going to connect the outer circle. And it should look something like that. Yes, yes? Yes, yes, yes? Okay. And then the other one. And then this one we know is I'm going to make it a little smaller. There we go. We know is a cardioid because it's 3 divided by 3, which is 1. So that gives you a perfect little cardioid, a perfect little heart-shaped. This is a sine. So sine, it's symmetric to the y-axis, but technically there's no y-axis here. So I just put that in parentheses. And then your theta comma r. You should do this. You should do it yourself. You should pause for 30 seconds, like now. And then you plug everything in, and then you get these values, and then you graph it, and then you get something like this. Yes, yes, yes. Okay, and then, so these are 2 versions of Limacons. So you can always do this chart, and it'll give you this final picture, okay? So this graph. But I'm going to tell you a little trick. So here's your little trick. You can write it or you can remember it, but there's a lot of rules, so I don't know. You do what you want, okay? So you can do this, but here's your trick. Positive sign means it's above here somewhere. Negative cosine means it's over here somewhere. Well, how do you know where the points are? A is 1. 1 up, 1 down. So most of it's here, but this is 1 up and 1 down. And then B is 3. B minus A gives you the length of the inner loop, which is 2. B plus A gives you the length of the outer loop, which is 4. All right, another one. Positive sign up here. We already know it's up here. All the stuff is happening up here. And then 3 is A, so right here and right here, out 3 to each side. And then 3 minus 3 is 0, so look right there, we're at the pole. And then 3 plus 3 is 6. Okay, normally I don't want you to graph something off our grid, but one little tick mark is fine, okay? So if you want to remember that instead of doing your 4 points, that's fine, but you gotta remember, okay? All right, example 3. So example 3, you have r equals 3 sine of 2 theta. Because of that 2 theta, it's not a circle. So we know that this has to be a rose curve. And it's a rose curve with 4 petals because 2 times 2 is even. So if it's even, you have to multiply by 2 and you get 4 petals. Okay, this is a sine graph. This is going to go it's going to have symmetry around the center, around the pole. Okay, not an origin technically. So it's called a pole. All right, so then all you're going to do is it looks like a lot, but it's really not. So 3 is how long the petals are, okay? So A equals 3. N equals 2, and that tells us we have 4 petals. So we already wrote that. If you don't want to write it again, you don't have to, but that's where it comes from. I think you should write that on your notes. Just write that, okay? The first petal, this is a sine graph. So the first petal is going to be 90 degrees divided by n. That's 90 degrees divided by 2 in this case, which is 45 degrees. So then my first petal is 45 degrees, 2 units out. And then I have 3 more petals, and they're all going to be evenly spaced. So, 360 divided by 4, and then it's going to be 90 degrees, 90 degrees, 90 degrees, 90 degrees. And when you draw it, you should be like, yeah, that looks good. That looks like if I turn it 90 degrees, it looks exactly the same. Okay, so you're going to try number 4. Try it for real. Don't be a cheater. Try it for real. Go ahead and what type is it? What's the symmetry? And then, all the stuff. Okay? Pause it. Do it for real. Just try it. See where you get stuck. And I'm hoping that you got that. So 3 petals, because it's odd, so it's the same number of petals as n. And then you're symmetric about the polar axis, which is like this positive x-axis or negative, it doesn't even matter, the x-axis that we think of. So a equals 2, n equals 3, 3 petals. The first petal just goes right there, and then I count out 2, and then it's 120 degrees, 120 degrees, 120 degrees, because 360 divided by 3 is 120, and then usually you can you can see it, okay? Okay, so how about this one? So this one, right here. What is that? I want you to think about it. I want you to say something out loud or in your head if there's people around. And then hopefully you got that it was a circle because there's no number in front of here. Otherwise it would be a limacon. And then it's going to have symmetry around the polar axis. So where's the circle going to be? You should know. The circle is going to be on the left side, like that. And then the diameter is going to be 4. That's it. That's it. Circles are super easy. Sometimes they're hard to draw because my circles end up kind of funny looking. But yeah, it's pretty close, right? Okay. And then this one, what is it? You're thinking and then you're writing down lemon skate. Yes. And then this is a sine graph, so it's going to go around the pole 180 degrees. And then if you had to guess, just look on front. What's it look like? Pause the video. Come on. Don't be a cheater. It's going to look like that because sine is 45 degrees. So then this is our first petal. And then I have a equals 3. And then so I go out 3. That's all it is. You're going to give it a try. The Delta Math is amazing. It's due on Sunday or, whenever you're watching this, it's due that next day. All right. I will see you later. If you have questions, I will help you later. But the Delta Math is still due. Okay, bye.